This video is about sketching and interpreting linear regression line. Dawn took part in a project investigating wind speed, x km/h, and the time, y minutes, to fully charge a solar-powered robot. The investigation was carried out 6 times. The results are recorded in the table. On graph paper, draw a scatter diagram to show the result of Dawn's investigation. Use a scale of 1 centimeters to represent 2 units on the x-axis. 1 centimeter to represent 5 units on the y-axis. Let's set up the coordinate plane. X-axis stands for wind speed, km/h. This is the y-axis, time, minutes. Origin 0. 1 centimeter, which means these 5 boxes, represent 2 units on the x-axis. 2, 4, 6, 8, and so on. 1 centimeter to represent 5 units. 5, 10, and so on. Before we get started, you really need to figure out the box scale. For x-axis, there are 5 small boxes between 0 and 2. 2 divided by 5 equals 0.4. So one small box stands for 0.4 km/h. 5 over 5 equals 1. 1 minute for each small box on y-axis. Then we can plot the points. 6:28 is here. 10:26 is here. 16:30 is here. 24:33, 28:38. 1F. Draw this regression line on your scatter diagram. We need to figure out regression line first. And then you need to figure out the mean point, x bar, y bar. When you draw regression line, make sure this regression line passing through the 2 points. One is the mean point and y-intercept of the regression line. Go to calculator, click on 1, then delete everything. Go to 4. Name the column 1 and column 2. P, enter. Q, enter. Put all the data in. Put the cursor on empty cell. Go to menu 4. 1. Go to 2 variable stats so that you can figure out x bar and y bar. P. Use this right arrow to get Q. Then enter. This is 2 variable stats. X bar is 19. Y bar is 32. make your cursor on another empty cell. Go to Menu 4. Enter. This time, go to 3. Linear regression line. Use this one to get P. Go down. Use the right arrow to get Q. Enter. We got this regression equation. Y equals 0.465x plus 23.2. The correlation coefficient equals 0.944. You can add another page, Control Doc, put calculator. Then go to these variables. Go down to this stats results. Enter. You could see this linear regression equation more clearly. Let's plot this mean point. 1932 is here. Label. Then the y-intercept, 23.2. Now, connect these 2 points. Y equals 0.465x plus 23.2. When G, hence or otherwise, estimate the charging time when the wind speed is 27 km per hour. This is a regression line equation. We will use it to estimate the charging time. Y equals 0.465 times 27 plus 23.2 equals 34.0 minutes. H, we already figured out from the calculator. Correlation coefficient equals 0.944. When I describe the correlation between the wind speed and the time to fully charge the robot, positive and strong correlation. For 1J, explain why it's valid to use the regression equation in E to estimate the time to fully charge a solar-powered robot when the wind speed is 27 km per hour. Let's look at this table. The interpolation 6 to 30. 27 is in this data range. There are 2 reasons. First reason, strong positive correlation. If the correlation is weak, you cannot use this regression line to estimate the time. Second, 27 is within the interpolation data range. 1K, explain why it's not valid to use the regression equation in E to estimate the time to fully charge a solar-powered robot when the wind speed is 40 km per hour. This 40 is out of this data range. That's why it's not valid. 40 km per hour is extrapolation or out of data range. 1L, explain why it would be inappropriate to use the regression equation found in Part E to estimate the value of the wind speed, because it's not reliable to estimate x using regression line y on x. If you want to estimate the value of wind speed, you have to figure out the regression line x on y, the wind speed on the time to charge. 1M. Done concluded from this investigation, there is no causation between the wind speed and the time to fully charge the robot. Briefly explain the meaning of no causation. Because the wind speed doesn't cause the change of the time to charge. Estimate the wind speed when the charging time is 32 minutes. We cannot use this linear regression line. You have to figure out another regression line, x on y. Control left arrow, go to this spreadsheet. Then go to this empty cell, menu 4, stat calculation, go to 3. This time, your X list will be Q, not P. Y list is P. Then enter. For this regression line, x equals 1.92, y minus 42.3. We know this y is charging time. This x is wind speed. So this x equals 1.92 times 32 minus 42.3 equals 19.1 kilometer per hour.